Today's lecture, we're going to talk about linear equation in one variable. So we're going to start with very easier one. We have 2x plus 3 equals 217. So when we're solving, we need to remember trying to isolate unknown on one side. In this case, your unknown is x, and move everything else to other side. So isolate the unknown variable on one side, move all these numbers to other sides to be able to solve for x. So in this case, the first thing you wanted to do is you wanted to subtract 3 from both sides. That will give you 2x equals 14. And when we're dividing both sides by 2 to isolate x is equals to 7. And we can always check equations. So let's say what happened if x is equals to 7. So put it into the beginning of the problem and see if we get 17. So 2 times 7 is 14. 14 plus 3 is 17. So we know that 17 is 17. So one good thing about solving equation is always we should be able to check our solutions. So we know this is going to be your solution for the given problem. What about the second one? This time it's getting longer. So we have a parentheses. So if we have a parentheses, that's something we wanted to get rid of first so we can combine the like terms, right? So let's see, we're going to distribute 2 to open the parenthesis. We're going to do 2 times x, which you end up getting 2x. 2 times negative 4 is negative 8, minus 5x equal negative 5. So from here, as you can see, you have 2 of the like terms. The term with the same variable, right? These 2, you should be able to combine them. So 2x minus 5x, you get negative 3x. And then you had negative 8 before, equal negative 5. And as you can see, you have 1x right here. So you wanted to isolate this. In order to isolate this from equations, you wanted to get rid of addition, subtraction before your multiplications. So we're going to try to get rid of negative 8 by adding 8. And of course, you need to do the same thing on the other side, which you will end up getting negative 3x equal positive 3. In order to isolate x, again, multiplications, you're going to get rid of them by dividing it. So you divide both sides of equation by negative 3. That makes it 1. So your x is equals to negative 1. And if you wanted to check your solutions, you can just always replace back into your problem, right? Replace negative 1 into your problem and see if you get left side and right side equals to. In other words, this left side should be equal to negative 5, right? So if you wanted to see that, it will be 2 times negative 1 minus 4 minus 5 equals minus 5x equals to negative 5. And this is going to be negative 1 also, right? So this should be negative 1 also. Then you get this is going to be 2 times negative 5 and negative 5 times negative 1. That is negative 10 plus 5. Is this negative 5? Yes. So we know our solution should be x equals to negative 1. Okay, let's try one other one that's pretty long. And look like you have double parenthesis. You have 1 here, you have another parenthesis on the other side. So the first thing I wanted to do is I'm going to distribute to open the parenthesis. So when I distribute 2, I get 2 times x, 2x, 2 times negative 3, negative 6, and you have negative 17. What about the other side? That will be this time distributing negative 3. So you need to be careful when you're distributing negative 3. Your sign change, right? So it will be negative 3x. Negative 3 times positive 2 is also negative 6. So that's how you change the sign inside of grouping when you're distributing the negative. And again, look like I have like terms here. And I have like term on the other side also. That's something that I can combine. I like to make it simplest form before I switch around the values so that I don't have to move too many numbers, because usually that makes problems. Okay, so then on the left side, look like I have 2x and then negative 6 minus negative 17. That is negative 23. And you have negative 3x before. 13 minus 6, that will be positive 7. Now I'm going to put number with the variable together on one side. So look like this two have not. Wait, let me erase that. So this two, you have like terms, the one with the variable, right? So I wanted to put that onto the left side because usually you are more familiar with seeing the variable on the left side, right? So that means you're going to add 3x. So no more x on the right side. And I need to add 23 so that I can put number without the variable on the right side. So on the left side, number with the variable, I will have 5x. Number without the variable on the right side, I have 30. And let's divide both sides by 5, where my x is going to be 6. Okay, what about if we have a fractions? So D, that's what we're going to see. If we have a fractions, the first thing I wanted to do is get rid of fractions, because if I don't have fractions like example 1, 2, 3, even this long one, I had no problem working on it, long as you know what you need to do. Many people have problems solving fractions. So if you see fractions, first thing you wanted to do is trying to get rid of all this denominator. If you can get rid of denominator, it will no longer be fractions. In order to get rid of 2 and 5 at the same time from denominator, you need to multiply by 10, right? So let's say you're going to multiply both sides of equations by 10 over 1, right? Both sides multiply by 10 over 1. Then this 2 will cancel out 10. You have 5 remains. So all you have right now on the left side is 5 times 3x, which will give you 15x over 1, which you don't really need to write it into the fraction form if you have over 1, right? And when you multiply this, you're distributing into two terms. So both terms get to multiply by 10 over 1. And 5 will cancel out 10, give you 2. And 2 times 8x, 16x. And 10 multiplied by negative 4, you get negative 40, because you do not have any numbers to reduce the 10. So you end up getting multiply 4 times 10. Now, no more fractions. This, I see the 2 unknown variables, so you wanted to combine that in one side. So in order to do that, I will subtract 16 from both sides. Then I get negative 1x. And you have negative 40 on the other side. And when you're dividing both sides by -1, you get x equals to positive 40. So that will be the solution of that problems. Make sure that when you're starting the fraction equations, trying to get rid of denominator will be the easy way to approach the problems. Okay, the next problem we have is example E. I see the parentheses, so I'm going to open the parentheses on the right side of equations. I get 2x plus 8. And when you're trying to combine like term by subtracting 2x from both sides, you end up canceling all x. So your equation no longer have variable x. What's remaining? I have -6 is equals to 8. So whenever you no longer have the variable that you had in the beginning, this times you're going to have either no solutions or many solutions. And when a variable is gone and this equal sign is not holding a true statement, for example, like this one, -6 is not same as 8, right? This is the false statements. In this case, no variable and false statements, then you're going to have no solutions. It means no matter what x that you replace, they will never be equals to each other, right? No solutions. So what about F? What about next, right? We need to open the parenthesis first. Then you get 6x plus 6 minus 2x. When you combine the like terms, you get 4x plus 6 and 4x plus 6. And before I go any further, I can see that your right side and left side, both sides is identical. So no matter what x you replace, this is going to be always equals to. So you know this is going to be many solutions, or negative infinity to positive infinities, right? Any number will always satisfy these equations. But let's say you didn't notice. If you didn't notice and you start doing a subtraction of 4x, so you can combine the number with the variable together. Again, all the variable x disappear. You have 6 equals to 6. So this is true statement. No variable and your equal sign holds the true statements, then you're going to have many solutions. And if we wanted to show interval notation of no solutions, then you can either use the empty sign, 2 of empty sign, either one. Many solution in interval notation will be negative infinity to positive infinity. It shows any number between negative infinity to positive infinity will be worked as the solutions. The next example we're going to look at is the proportions. It's proportions because it's saying one fraction is equals to the other. So they are proportionally equals to, even though they're not the same numbers. Here, you can do these types of problem 2 different ways. So whenever you have one fraction equals to one other fraction, just one fraction on both sides of equal sign, you can either use cross multiplications. So you're crossing multiplying this 2. So you will end up getting 7 times x. And you get 63 times 5 on the other side. And if this is a proportional, this always comes true statements when you cross multiply. So this is going to give you 7x equals to 315. In order to solve for x, you're dividing both sides by 7, so x should be equals to 45. So this is one way of solving it, and we use this method as a proportional method. We're assuming they're proportional, so if you can cross multiply, that should still be equals to each other. You can also do these types of problem by getting rid of the fractions. So if you wanted to, let's say we have the same problem, and if we wanted to get rid of fraction, because I mentioned that whenever you wanted to solve fraction equations, you wanted to get rid of denominator first, right? And if we wanted to do that, we're going to multiply both equation by 5x, right? We do multiply 5x. So that way that this will cancel out. There will be no more denominator. And this will give you 5 times 63 and 7 times x, which is going to be the same thing as this method, right? So either way, you should end up getting the same answer. So for that fact, if we were going to look at example B, and if you wanted to use the proportion method, because that's the example above, then we're going to use the cross multiplication again. It means you're going to multiply 2 times x and 30 times x minus 10. And this gives you 20x. And when you distribute 30, you get 30x minus 300. And combine the like terms. So you're going to subtract 30x from both sides. You get negative 10x equal negative 300. When you're dividing both sides by negative 10 to isolate x, you get positive 30. And that is the solution for that problems.